All right, here's example 4. There are 5 television shows you want to watch before your class. It begins 74 minutes later. If you randomly picked 2 shows to watch out of those 5, what is the probability that you will have finished watching both shows before your class? Now, it's helpful here to keep in mind the question, even though it doesn't ask here, what is the random variable? Okay, because don't be tricked. Because here it shows the shows, show A, B, C, D, and E. And it shows the minutes, how long each show is, 38, 30, 35, blah, blah. But it doesn't show you the probability distribution at all, right? In fact, it's not like there's a probability distribution for A, right? How likely is A? I don't know, equally likely as B, C, and D, right? Because you just pick randomly. What we really want to know is how many minutes 2 shows will be when they're added together, right? So picking 2 shows and getting the sum of those 2 shows. So eventually, what we really want to have is, sum of the length of 2 shows, right? And so we want all the different combinations, like AB, AC, AD, right? And all their sums, and then the probabilities of those sums, right? So what's the probability of picking that? Okay, so that's going to take more room than what we have here. So if you pull up this Excel file and go to example 4, I've put this information on here. What you might want to do is first start off with just looking at the sample space. So let's start with the sample space. And the sample space might look something like this. So first, we want all the combinations with A as the first show that you pick, right? And then B will be the second show. Oops. C will be the second show here. D will be the second show. So maybe it's helpful if we label these. So first show, and then first show time, second show time, right? So we have all these different things. And later what we can do is get the sum by adding this and this, right? So we could do that later. But let's create the sample space. So the next combination should be all the combinations with B as the first show, right? And then A will be the second show. And then C, D, E as the second show. So next we have all the combinations where C is the first show. And then A and B are the second show. D and E are the second show. And now let's go down to D being the first show. And you could have A or B as the first show, C as the first, A and B as the second show, C as the second show, or E as the second show. Presumably, you don't want to watch A after you just watched A, right? And then finally, we have E as the first show, and then A, B, C, D as the second show. Great. So now we have all these different shows, all the combinations, and we could quite easily calculate the sums. Ta-da! So these are all the sum total minutes, right? Now, what we probably want to do is sort these by sum, right? Because eventually we want a probability distribution that will use sum. So I wonder if this will work. So a little bit of a delay, but here I wanted to sort by sum Because eventually, we want to have a probability distribution that just has these sums on it. We don't really care if 63 was created by watching B and D or D and B. We just really care that it adds up to 63 minutes, right? So now I'm going to go over here and start my probability distribution. So here, I'll put sum. And I have a couple of different sums here. For instance, I have 63. That's a sum that comes up. 65 comes up. 68 comes up. 70, 71, 73, 75, and 78. And I want to know how likely is 63 given all of these potential different combinations. And these are all equally probable because, each show has a 1 out of 5 chance of being picked as the first show, and then a 4 out of 5 chance of being picked as the second show. Or not 4 out of 5. 1 out of 4 chance of being picked as the second show. All right, so here, what we would do is maybe we can use a formula. So we can put count if, and we could say, in this range, and this range we should just lock it down because it's not going to change for us. In this range, count it if it is 63. And then let's put all of that over however many different combinations there are. So that's all of this. I think there's actually 20 combinations, but this way we could have Excel do the work for us. We're locking that down. Once I do that, so since it's 2 out of 20, that ends up being 1 out of 10, which is 0.1. But what we could do is just copy and paste this all the way down. And so we find that most of these are equally probable, like 63, 65 minutes as the sum. But 68 minutes is twice as likely, because it's 4 out of 20, right? Twice as likely as these 70 minutes or 71 minutes, right? So here I'll put the probability of these particular sums. Now, what ends up being helpful is to look sort of back at the question and say, okay, now that we have this, what do we really want to know here? If you randomly pick 2 shows to watch, what is the probability that you will have finished watching both shows before your class? And let's say you could arrive at your class instantaneously, so you could use all 74 minutes to watch. So the cutoff would be around here, right? So we could watch all these different combinations and still be under 74 minutes. These are the only combinations that are sort of not under 75 minutes. So the way that we would write this in probability notation is P, where X, the sum in this case, is less than, well, we don't have to worry about equal to, so less than 74 minutes. What is that probability? Well, you could just add these probabilities up using the addition rule, right? You could just add these probabilities up, right? And so in order to get that, we could put the sum of all of these. And that should give us 80%. Because the only 2 we're leaving out are these, and each of those have a probability of 10%, right? So if you randomly pick 2 shows to watch, there's an 80% probability that you will finish watching both of those shows before you go on to your class. So nice and helpful of probability to help us figure out our TV watching schedule.